Okay, hello everyone. We are back doing more Wolfram language design reviews. This is a language completeness and consistency meeting. Our first topic is propagate aborts.
Right, so you should open the new rough page, and actually there are probably some others we should take at least a quick look at. And I committed this last night around between 2 and 3 a.m. So
okay, so we might not. It's probably not in my version yet.
Oh, yep, it's there.
Okay, how does this relate? Okay, I know we've talked about this before, but I don't remember all the details of what point was.
Right, so there's this issue of when you call check abort, do you know, does check abort swallow the abort and it's no longer to be seen anywhere, or does it persist past the check abort? And the behavior we've had up till now is that if it's a user abort, as in you hit Control-C, or there's an explicit call to abort, or you select abort from the interrupt menu, then check abort swallows that abort and it goes on its merry way. But if you do a memory constrained or time constrained, then the abort persists past the check abort. So you can react to the abort inside of the memory constrained, but you might still want the evaluation to actually stop, so you persist the abort. So
yeah, I think it was worse than what you're saying, Itai. I think it was buggy and did not even abort inside. Time constrained would not properly abort inside check abort, if I remember correctly.
So I don't understand. Abort protect is like propagate no aborts, correct?
No.
Ugh. Okay, why not?
Because abort protect says don't allow any aborts in this thing to be
activated.
While this code run. This run calls to completion. Now
they can still be raised.
Right.
And so at the end they will splurt out.
Yes.
Correct. And then so check abort, right? Even a check abort, even inside of an abort protect, will detect those aborts and react to them. And then the question is, does the check abort allow that abort to persist, or does it not allow it to persist?
I get it. How does this relate to confirm and close and its conventions for propagation? Maybe Christopher can comment on that.
I have to think about that.
Right. So I think, confirm and close are sort of more analogous to throw catch, right? And so, when you throw, it's like, do not pass go, do not collect $200, go directly to catch. I suppose there are possibly a couple of exceptions to that, but that's more or less the idea.
But the catch does not propagate then.
Right. Once it's caught, then it's done.
So the check abort with no propagation will be the analog of a catch.
Correct.
Right. Whereas,
so that would be propagate aborts goes to false.
Yeah, you'd have to maybe have a nested throw to be analogous to a propagation of one level.
How does that work? If I say throw of throw, do I have to say catch of catch to catch
it? If you give second arguments.
I think it's worse than that. I think you have to do throw of unevaluated of throw in order to need a second catch.
That's probably true.
Yeah, I think having throw of throw, the inner throw will just run. But I think that the right. Actually, there's been some there were some uses in some error handling contexts where, maybe this is only for fairly niche internal stuff, but where it would be nice to have stuff for basically propagating throws as well. I mean, basically where you want it so that you have a throw and then you have a catch that looks at it and then makes a decision about whether or not this throw is relevant to it. And if it isn't relevant, it just throws it again. I don't think it makes sense to have an actual construct for that, but it's a similar flow to this.
And what about, by the way, there's an error, there's a spelling mistake here, memroy.
Okay, well, I can fix that.
I know you can fix that. I was just pointing it out since I noticed it. Okay,
All right.
there's a different case, which is the propagation in the event handler. Right, event handler has some kind of propagation of events thing, does it not?
Right.
But I think that's a little different, because with event handler, what's happening is just because you're interested in a mouse event doesn't mean that you should prevent other things that are interested in mouse events from seeing them. Whereas throw, right, either the inner catch grabs it or it doesn't. It's not that the inner catch is going to do something and it's not doing anything because the code flow is going to an even outer more one.
Okay, but so this notion of pass events down, pass events up is irrelevant. The things we're talking about here, is that correct?
I think so. At least my mental model of these things doesn't include it, and maybe there's something funny about that you could think about with a third argument to catch, which would contradict me. But
okay,
I'm not seeing it.
Okay, I mean, this seems like, okay, so time constrained also has that. So time constrained, do we say that time constrained generates an abort? Do we say that's how it works?
Yes, we do.
We do, and that's not entirely true. So you'll see a note and then beneath it a tentative note, which is basically replacing, cutting out the not true part that a time constrained abort. That a time constrained abort is exactly the same as a normal abort. I mean, that's just never been true, and I don't think.
I thought that we changed it so that it was true, Itai. I could be wrong.
It's clearly not in check abort, right? I mean, check abort behaves differently.
Yeah, okay, yes, that was for a few reasons, including backward compatibility. But if you set propagate aborts to false, I believe it is then the same. So yes,
Correct.
It's the non-default setting, and that was by intent. Discussion with Roman and others.
Right. Yes. I mean, it took us literally years of discussion to
6, I think,
to settle on this design.
Which design?
So that the default behavior of check abort is that, what we internally call aborts are swallowed, but that time aborts and memory aborts are propagated.
Okay, so wait a minute. So what is the change what was the proposed change to time constrained?
It's really just the wording, right? So rather than saying that aborts generated by time constrained are treated exactly like those generated by abort, it's to just say that aborts generated by time constraint can be, yeah.
Okay, all right. I think this seems reasonable. Anybody else want to complain or anything with this? It seems reasonable for now. I mean, I can imagine some even more elaborate abort control thing, but I think it's one of these things where, as I've said multiple times, and I hope we're going to restart these message handling meetings. You have the primary code path where nothing goes wrong, and there are no aborts, there are no messages, there are no errors. And then we've got the secondary code path where one thing goes wrong. By the time we're at the quaternary code path, where 2 different aborts happen that intertwined with themselves, we're dealing with a very obscure case. And I think this is what we've got here is a reasonable handling of what one might call the secondary code path that involves a single abort and how it's handled. Is that a reasonable analysis? Or
I think so. I mean,
Yes.
right, this also comes up with like, I mean, the reason Roman was involved, right, is distributed computing, right? You might want to somehow communicate these, right? You have this code that, and you need to distinguish between the aborts of the thing that's running the code and the user code. And so, you know, there are uses for this. Something more elaborate, yeah, it's, I think we have a sense of what will happen, but sort of customizing, I don't see an obvious use for it.
Right. Okay, well, fair enough. Okay, seems reasonable. So should we go on?
Okay.
System exception. God, what is this?
I'm curious if why. Oh, are you in 13.1 maybe? I'm a bit confused by why you're.
Yeah, and it's 13.1. It's our recent shipping version.
Okay, so well that explains why that output looks kind of funny, right? So I mean, we talked about this in the spring, and we decided not to do anything for 13.1, and the question is, do we want to do something for 13.2? Right, so
What is the question exactly? Go ahead.
So the question is how to handle you know, running into recursion limit and iteration limit. So right now we issue a message and we try to return some sort of, you know, partially evaluated thingamabob. And the idea is that we should instead just, you know, generate an exception and, you know, indicate that.
I should add that as currently configured in our evaluator, we are not always successful in returning this partially evaluated thingamabob, even inside a hold. Sometimes we end up going back into recursion. We have crashes from this all over, not all over, but several bug reports.
I think this is, again, a story of a sort of the quaternary code path and so on. You know, it's like first there was an error, then there was an error to the error, and so on.
Yeah, that's what causes the recursion type problems to, you know, when they crash, it's because of those, I wouldn't call it quaternary, tertiary maybe.
Yeah, okay, right, fine. As opposed to transfinitely infinite towers.
Right.
Right, yeah, as opposed to that, that wasn't the first thing that came to mind, but yeah.
Although I suppose if you really wanted to do it consistently for everything, it really would be a transfinite tower, is my guess.
That's right. Right. I mean, and so the question really here is, how close are we to the possibility? I mean, this is the circular data structures, infinite data structures story. And, you know, in the next few years, are we actually going to get those? Because if we are, then many of these things will turn into one of these bizarre transfinite data structures.
I'm not convinced of that. I think, you know, maybe the example we're looking at here, but I still think we're going to run into recursion stack issues and less common, but the iteration limit, which is really reevaluation, sort of misnamed. I think we still run into both of those, even with infinite data structures.
Well, you're right. An infinite data structure is just a representation of a simple case. And there's no guarantee that these are being generated in a simple way. They could be generated in some incredibly complicated way.
Yeah.
Right. I mean, it's like the Turing machine that just wiggles its head back and forth. And that can be represented as a sort of just a loop of some kind. So yes, I agree that the, I mean, okay, you can no more foresee the infinite data, you know, the infinite loop as you can foresee the halting of the whole thing in general. So there can be, you know, again, we're submerging into this sort of marsh of complexity, that there can be a case in which it is, you know, generating random gunk infinitely, so to speak. as opposed to just looping infinitely, where there's a, it's like we can represent infinity by just a symbol, but we can't represent these infinite structures in an easy way. I mean, or we could, like, our basic data structure is a tree, but if we allowed it to be a DAG, we could represent a bunch of these infinite things, I think.
It is a DAG, our basic data structure. It's the acyclicity that kind of prevents
what's
that
that word?
infiniteness.
Well, but it's secretly a DAG because it's a copy on write kind of thing. So it doesn't actually behave like a DAG.
Yes.
Okay. In any case, if it's acyclic, it's not going to have that capacity for representing infinite structures.
Although you can with unevaluated stuff, or like with hold all stuff.
Yeah, true.
Because you can have
Sure.
expressions that contain
Yeah.
themselves, and yeah.
So
there's ways to do it with, as a side remark, with
So what's
expert
the question?
backs.
What's the question?
Whether or not to enable this as default handling, where a system exception gets thrown rather than allowing for the current behavior.
Right. Can it limp after it's been recursioned out is basically the question. Or do we just, or is it euthanized or something rather than limping?
I prefer that latter, because years ago I actually made some changes which allowed it to limp more frequently than just cause crashes. But it's, with this limping, it is impossible to stop it from just getting back into trouble.
Yes,
I generally think that limping is, if you know that something has gone wrong, limping is bad. But maybe actually, I mean, here's a naive question. What is even the purpose of recursion limit and iteration limit?
To avoid it running out of memory, to avoid it running, at least in ancient operating systems. I don't know if what's the case today, but back 35 years ago, if you ran out of stack space, it just crashed, and there was nothing you could do about it. There wasn't
Still
even,
does.
But
Still does.
yeah, but when you make a function call in Mathematica, is it actually? I mean, it's not like the arguments of that function call are actually stored in the stack.
but they are. The evaluator is actually recursing on the stack.
Yeah, anytime you go into the IEval evaluation loop, you're using recursion in the C.
Right, and it's actually worse because
stack.
it's about a factor of 10.
Right.
Because we have 10 functions we call to do one function call.
Yeah, it might not be 10, but it's at least 5.
Yeah.
So what is the, just out of maybe if someone knows off the top of their head, because I know that like at least a few years ago when I was looking at this on Mac, it was like I think 16 megabytes, 16 megabytes was the default stack size. So I mean, how deep does that let you go?
Typically, on Linux machines, that at least the ones I've worked on, you get maybe 60,000 deep on the subroutine stack, maybe.
For the IEval calls, or for
no, I mean 60,000 calls complete, altogether, which means if IEval is every 5th or so, then divide by 5, 12,000.
Yeah, right. So I mean, back in the day, we let malloc just allocate away heap memory for expressions, and we took the principle that the system should just keep doing that until it ran out of memory. You're reminding me what the issue was. The issue is fixed stack size allocations in operating systems.
Yep.
Because even though the stack is growing down like a stalactite or something, it typically they don't allocate that. They still don't allocate dynamically.
Right. And I'm not even sure you want that. I mean, yeah, if you have more memory available, it might be nice, but
things have gone badly wrong.
Generally
by the time
speaking,
you've gotten there, it's gone badly wrong.
Yeah, exactly. You're
So-
not likely to save yourself in many situations. It's more likely your code had a problem already.
Well, what about is iteration limit the same problem, or is the
I think it does kill recursion. It does kill
No,
it.
that can cause it, but yeah, there are other reasons that we get into infinite reevaluation. Tail recursion is one reason, yes.
Right. I'm just thinking of, I mean, some of the, for example, we had a summer school student this year who was doing some things with, infinite data, infinite self-referential data structures. So where, they have a hold all argument and they contain themselves and stuff like that. And one of the issues was that you could run into cases where you'd hit the recursion. I forget if it was the recursion or the iteration limit, but it didn't seem like there was any fundamental reason why, it would, in some of these cases, you understand why, oh yes, it really needs to store all this information in the stack in order for it to work. But there were cases where it didn't seem like there was any fundamental reason why anything needed to be stored in the stack. And so I'm just wondering if, in those cases, whether the recursion limit is sort of an arbitrary, an arbitrary restriction.
Right. I think the recursion limit, and one would have to look at the code to know, but I think the recursion limit is sort of separate instrumentation, not directly related to actually seeing memory build up on the stack.
It's related to subroutine call count, though, and I think that is directly related.
Okay.
I mean,
denies what Chris was saying, right?
You
Right.
for recursion limit, not for iteration limit.
Right. Iteration limit, right. The problem is, yeah, I mean, I suppose that, I think it's mostly just that probably if you've gone on long enough, you've probably gotten yourself into a loop. But I mean, that's going to be heap exhaustion, not stack exhaustion. If
it exhausts any resource, it would be heap, yes.
Right, but as a general note, I mean, we usually don't care about heap exhaustion. If I make a table with 100 trillion elements, it'll try and do it and fail, right? I mean, it'll just eat up all my memory.
Right.
Well, you'll get
as long as
a
100 trillion,
SystemException.
as long as 100 trillion is less than 2 to the 63rd, right? Because it won't.
Okay, fine. 2 to the 63 minus 1 or something.
Yeah.
Yes.
No,
yeah.
Well, you'll get a malloc will give you trouble, but if you try to do this like one at a time, like you're creating a linked list or something, hard to say for what will happen. Maybe it will
eventually malloc will return null, and your process will crash.
Yeah, that's true.
Right.
Just like here, eventually the stack will be overrun and you'll crash.
Right.
Am I remembering correctly that it was actually even worse than that back in the day when we originally implemented this, that actually the operating system would crash? I'm not sure.
It's entirely
I won't say it couldn't happen.
It's entirely possible with the operating systems of the early 90s that you could consume enough of the stack that the kernel would go wonky and crash.
Yeah, I know the Commodore 64 stack would just wrap around and overwrite itself.
Ugh.
Right.
Yeah, that's
it's
your
possible
operating
that we've
system
made
crash. Yeah,
it's possible we've made an advance since the Commodore 64, thankfully.
I've repressed.
Hopefully.
Yeah, I've just repressed too many memories of that era, so I can't tell you what happened then.
Okay, but the concrete question here is, there are cases where, I kind of wonder whether we should have a recursion constrained function, because right now you can say block $recursion limit equals blah, right?
Yep.
But I don't trust that, because I think it's going to limp after it fails from that. But what I can imagine being useful is, let's say you get one of these system exceptions. Okay, you've got a list of evaluations going on. You're computing Ackermann functions or something. I don't know what. And you've got the first 4 and they work fine, and then you've got one that blows up. It's annoying that the whole thing just returns blip. System exception, you're dead. You don't know even where it happened. Am I making sense?
Yeah, that is a drawback. Still think it's better than the options, but it is a known drawback to the system exception.
Right. Also there's another point to make here, which is there's pieces of the evaluation that were successfully completed before the recursion limit was hit.
Yeah.
And yet you're not returning those.
Well, in a way, it's like your own damn fault. Use catch. It's throwing a system exception, and I think the message says you can use it catch to
Well,
to
so
catch it.
there's one of the issues that's very irritating is that so this does so you can't easily just put it would be nice if we could just have a tagless catch any of these things, but they don't. So you have to know to catch a system exception.
Well,
Yeah.
because I don't think you want generic catch to do it, because then then you could have some totally bizarre thing happening in code that you've got a catch there for some completely different reason, but you blow up the stack and then your catch catches it and everybody's confused. So I don't object to the fact that this is a not defaultly catchable thing. But look, what I'm suggesting.
It is catchable.
No, not default catchable.
Well, the default is the thing that is crashable, crash prone.
I know.
Yeah. So let me just point out that that formatting there, right? That's make boxes actually catching the system exception and saying, right, and that you can use that as input. It will interpret correctly. It'll just it just says, well, rather than pinking or crashing, it's just like, well, make boxes ran into trouble, so I can't display it, but your result is safe with me. So you can. All I'm saying is you can do something with.
So you're saying I could say depth or something there on that object, and I would get a reasonable answer.
Yes.
But that thing is very incendiary. I mean, it's a little recursion bomb or something, right? The thing that you get out from recursion limit has extended itself right out to the limits of recursibility, so to speak. And if you fed it into something else, it would blow up.
No, because it's the make boxes rule that blew up, right? So if you give it to depth, it'll give you 0 or 1, whatever it is that depth will give you, because G is fine.
Yeah, okay, so your point here is, I see, I hadn't really understood this. This is recursion blowing up inside the formatter as opposed to the evaluator.
Right, exactly.
And that actually is, I think, a separate issue, Itai, you and I discussed, with some ideas about maybe scaling that back by changing top eval a little bit.
Yeah, but I think
not for 13.2.
Well, I also think that, I think that's a somewhat orthogonal.
So we've got two different issues. One is, do we, as soon as we hit a recursion limit, do we blow out with a system exception and generally return to top level unless somebody put in a specific catch? Or do we do what we're currently doing, which is to attempt to limp on with evaluation? And you're saying,
what I'm saying is that if there's a system exception, then make boxes can catch it and do something sensible, which is to return an object which doesn't display the expression, but is usable as the expression.
No, wait a second. You've got a different case here, which is that make boxes itself generates an internal recursion limit. That's
correct.
Different. Okay, right. So you've got two different things. One is the wrapper blew up, and the other is the thing itself blew up. The first case you're showing here, where the actual evaluation itself generated a recursion limit, which potentially goes to a system exception, is different from the case where the attempt to display that thing generated the system error.
Right, but my point is make boxes goes through the evaluator, right? After you're done.
Yeah, I get it. It's a secondary pass of evaluation.
Right.
And there are other secondary evaluators as well.
Right, and because there's now a system exception, make boxes can catch those and do something sensible in the case where that passed through the evaluator, produced a recursion limit error.
Well, I thought the thing being fed to make boxes, if the actual expression is a system exception, then make boxes will just get that little
There is no system. No. There's no system exception. I mean, right, you can type in system exception, right? System exception has no formatting rules. I mean, you can see that in the previous output. The point is that there, system exception is generated while makeboxes is formatting G. And so rather than peakboxing or crashing the kernel or various other bad things, makeboxes says, oh, look, I caught the system exception. Let me return this template box, which doesn't display the expression.
Yeah, I get it. I get it. But that's an exception generated during formatting. And I agree with you that the thing you're doing here is pretty much the obvious thing to do, rather than pink boxing or crashing. I agree with that. The question is, the different question is whether the correct behavior, if you have a list of things, one of which hits a recursion limit, but the other ones do not, whether what you want to return is 1, 2, 3, recursion limit thingy, hold, or whatever, or whether you want to just say, boom, you are out of luck, the whole thing returns system exception.
Right. And obviously you could, you could make the first thing happen by, if your table has a catch of,
But I'm saying, I think that will be good to happen by default, which is what's been happening for 35 years or whatever.
Right. So basically, you're suggesting the table would automatically have a catch.
No, I don't see how this works, Stephen. Once you start limping, I mean, you're basically dead in the water, and you're saying, well, we should return what we already computed, partial results, and
no, I mean, I think it's a different.
No. You've got an expression tree. Yeah. You have been constructing an expression tree. You are in the evaluator. You are recursing. Something blows up in the evaluator. Okay. You're at element 4 in going through a list because the evaluator sequentially goes through a list. Okay. You haven't done the other elements.
Well, if you've hit recursion limit, what's going to happen is you're going to have this deeply nested expression that you're returning with a hold around it. And so you're just going to go right back into the recursion when, if you try to, for instance, print it out. Even if you don't, you're
no, I agree with you. I agree.
You have this huge.
I know. Taking this exploded object and returning it is asking for trouble, right? The question is only whether basically it causes an explosion that causes everything you're evaluating to disappear, or whether it is merely this particular thing. It's like, the Titanic or something.
But how do you delimit that thing?
Yeah.
You're in a table and you've evaluated 3 elements.
How far do you go up?
Yeah, exactly.
So okay, fine. So
that's why I'm saying you need to put in that catch explicitly. If you know something.
Your argument is deep in the depths of recursion, the whole thing just went infinitely. And the question is, do you have I don't know, what did they call them, in the Titanic or something? Do you have the compartment, thing that you can close to prevent?
Right. We don't have a way of demarcating these compartments other than
explicit catches.
Yes, exactly.
Okay, so that's the issue. So the issue is
this is, by the way, it's very related to. I mean, I haven't heard about this in a while, but I mean, there was all that stuff in the error handling working group things about some proposal for sort of a more generalized kind of exception system. That, I mean, if that ever gets implemented, then long term, that's how this should work, basically.
What's happened to that error handling discussion?
They were supposed to send out a proposal shortly after 13.1 release, and they haven't. So,
so somebody needs to be bugged there about that. But okay, to me, this is not fully cooked. I mean, this is a complicated problem and a very interesting problem, and a problem that relates both to error handling and to infinite data structure questions. But I mean, I do understand the issue, I think, now. Basically, the point is something went bad. the thing went off infinitely. It will eventually blow itself up and run out of memory. Fortunately, we've instrumented it to the point where we know that's about to happen and we stop it. But once stopped, I mean, you see, the way one would do this, okay. You know, again, this is different layers of pumping out seawater, so to speak. Okay, you know, clearly it's like when you have a memory allocator and you give it some headroom and you say, you know, have the program start to exit when you are at 90% memory allocation. If you see what I mean. In other words, be allocating ahead of where you need. And if you start seeing malloc return null, then back out and give yourself a certain amount of headroom for your escape path, so to speak.
We kind of try that. It doesn't work so well, but we kind of try that now.
You say we try it in the
We do try it in terms of the error messaging.
Okay, but I mean, so what I'm saying here is we could imagine a situation where, yes, you have, I mean, the basic problem is the code path in which the recursion limit has been hit is not a stable code path. It's not a well-explored code path. I have no idea what tests have been done on it. You know, I don't know. If you have a largely recursioned out expression and you feed it to find shortest tour or something, what the heck does it do? Am I making sense? But I could imagine in a horrible pump out the seawater kind of scenario, you could say, this is a bad idea, but I'm going to say it anyway. Once you've hit that limit, you could have a thing that kind of lets out, like one of those suitcases that has extra, you know, it has an extra thing that allows it to be an inch, you know, taller if you really need it to be. You know, once you hit that limit, you let out the stops and allow it to go a little bit further in the hopes that it will successfully limp its way out.
We kind of, that's kind of our default now, I believe. Not exactly like that, but at least for recovering from the error, we try to reinitialize you know, the recursion limit to back it out. And I don't think we're doing it very well. That's what I was, you know, that sidetrack with Itai several minutes ago was kind of related to that, where we could improve it. But it's not that we don't do this at all. We actually do, I think.
Okay, this is a truly complicated issue. I mean, look, I think your point about make boxes returning you're out of luck, that seems fine to me. This question about whether we return, boy, what about the possibility? Is there anything incendiary about the expression itself? If we froze it completely, which is what we're trying to do right now, is the expression itself incendiary?
If you try to evaluate it or print it, yes. Otherwise, I don't think so.
Okay, but so if it was encapsulated in a failure exception type object, and you had the whole thing there. Okay, the other thing, I mean, again, this is a pumping out seawater kind of scenario, but the other thing one could do is keep it in the failure object and simply try and chop its tail off. So in other words, you look at the expression and you shallow it, so to speak. You say anything deeper than such and such an amount, just chop it off. And then you put that expression in some kind of hold and you say, this is probably going to be safe.
Well, what if we put in one of these inert expression things?
Which inert expression things?
Well, the one, the data structure,
Oh, I see what you're saying.
that Tom set up, that's completely inert. So you can examine it with a loop, for example. Look at the, you know, write a loop that goes through the heads that's not actually recursing, right? So
I do have a question about all this though, where you've hit this recursion limit and you're coming back up, I guess, for air. I mean, when you hit it, you're at the bottom. It's not as though you have access to the depth and all that.
I know. So
I'm just not sure how this works.
Okay, so here's the point. You hit it, and it says, we're done here. You've got to just come back up. Okay. But what I would suggest, I don't know exactly the implementation, but let's say you come back up. You don't know the depth. It doesn't really matter that you don't know the depth. If you come back up and you are, this is again a headroom kind of idea. You're down at the depths. You say you hit the bottom, you can't go any further. Now you recurse back up. You go 50 levels of recursion back up. And you say, I'm going to chop off that 50 levels below me, that tail that's 50 levels below me, and I'm going to put some recursion end marker in there. And then I'm going to come back up, telling the system that I hit the bottom of the recursion limit. See what I'm saying? I think this is not a completely stupid way to handle it. In other words, what you end up with is a safe expression where you hit the bottom, but then there's a secondary, recursion, a recursion back off number, which says, given that you hit the bottom, you back off. Let's say you halve the recursion depth, and you insert there a plug at the end of this thing that says we're not going to go any further here. You put in that you cap off the deep drilling thing or whatever, and you just say this is the end, and then as you come back up, you say I hit trouble down there. Now the fact is, if you've cauterized
I think a more sensible solution is you get to the bottom, you convert what you have there to a data structure, and then that's what it evaluated to, and you work your way back up. And assuming that conversion to a data structure is safe and doesn't take a spec through the evaluator, then
that's possible. It's possible. I mean, I think that's nice, but I think it's slightly unnecessary. I mean, I think you're providing you're giving too much luxury.
That's the person who hasn't looked at all the bugs of when things go wrong because we try to return this, what we have wrapped in holes.
So, I mean, I think what you're thinking about, Stephen, is great, but the number of cases where people would actually use it is
I know, but I'm saying you're zero. Okay, listen. I'm saying you cut the tail off as far as you want to cut it off, to the point where you're sure it's safe. You wrap it in a hold and you return it. And then, yes, you're right. You're losing some information because it actually went a lot further. It actually recursed further. You're not storing that later recursion because it's not safe to store the whole thing, at least not as an ordinary expression. What you're proposing is converting to an inert expression, which which I think is fairly confusing to people. I think that most people who hit this, I mean, I know I've hit this a bunch of times, and it's just like, oh, I just had to go a little bit further. Oh, that's annoying. Sometimes I even increase the recursion limit. And it just makes it through if I increase the recursion limit. But I mean, I'd be perfectly happy if it just said, it ran out of recursion room on this element 7 out recursed itself, and then element 8 keeps going, and so on and so on and so on. And I just returning this blob that represents I went too far, because the thing doesn't hurt itself right when it's at the bottom, when it's hit the recursion limit. No damage has occurred at that point. It's protected itself from damage. The only place where there's damage is returning that big thing, which might then be re-inspected. So just don't return the big thing. Just cauterize that big thing, chop its tail off. Does that make sense?
Well, say you're in a nested table construct that ends up being infinitely nested. Where do you, which point do you, yes, you can arbitrarily say, I'm going to go back up, 3/4 of the recursion stack or something like that. But
well, how do we do it right now? We stop at some point. So I see.
Well, right now,
I don't know how we unwind. I agree. I don't know how we unwind, and we didn't put in checkpoints, so I don't know how far we have to unwind. I admit that. And I still argue for a function recursion constrained that would control this stuff a little bit more, and where recursion constrained like time constrained, is just the way of is it what we could even think about is that our default, just like right now,
Well,
the main
if
loop.
it's called recursion constraint, then I would expect it to generate an abort.
Exactly.
And then
Yeah.
you'd have to catch it with check abort or whatever.
Yeah, right. But what I'm saying is, right now, the main loop has no time constraint, no memory constraint by default. We could give it those. People could give it those. I'm saying the main loop effectively has a recursion constraint with $recursion limit in it. I'm saying maybe we should make that explicit.
Well, that can be done, in the hacky way of using block $ recursion limit equals whatever.
Yeah. I'm not sure. Okay, we've had a useful discussion about this. My feeling is that I understand your point. We don't know how far to unroll. Yeah. I think this requires a bit more thought. But I do agree that your thing about what to do with the print, printing is reasonable, but can that be done without solving this other problem? No, it can't, because you have to have this encapsulated system exception before you can do that.
Yep.
We need to discuss this some more. I'm sorry. This is not, I don't think we've solved this yet. Sorry.
Can we do the with one? Because that one should be very short.
I didn't know that worked. Cool.
I don't think anybody else did either.
Lou found it by accident and asked if
When
it
was
was
it
by
implemented?
intent.
When was
Probably a long time ago, looking at that code.
that? Like 30 years ago or something?
Could be.
Yeah, this could very well date to version 2. I mean, I've not gone back and tested it, but
Yeah, I suspect it does, looking at the code and comments. It looked like it was actually designed to do just this.
Shoot. That's
This
good.
is bad. What it's doing, I mean, maybe it's obvious to you, but it's just not evaluating val prior to the assignment.
Cool.
So it actually works harder at the beginning, at least, when it's set versus set delay. Set delayed.
Yeah.
Right, but if you do x : random real,
It'll keep reevaluating.
Yeah.
Presumably, if you do that, it's what you wanted.
Presumably, Dan.
All right.
I've seen Francisco using this repeatedly.
This thing here.
Yeah. He told me long ago. Yep. I don't know how
it works.
It's
I just tested it. It works in version 3. I don't have version 2 handy, but I suspect that, like I said, it goes back to version 2.
It could go back to 1, couldn't it?
Yeah, it could.
No, width was new and
Width was new. Okay.
This is the point about returning. What is the point here? Returning a modern region object or something?
right.
Yeah.
Well, yes. I mean, it's one of those things where you sent out an email with a subject line and no content and expect us to read your mind. And even though I think I'm pretty smart, I can't actually read your mind. So I took some of the comments and tried to figure out what are some useful discussion points.
I have things to say about this.
Yeah, I mean, I've complained about this several times. Although I had a useful discussion with Jose about this in person. I mean, basically, the issue is if you ask for instance, the here it's the polygon for the world, and it gives you this geogroup filled curve, et cetera, object. The problem is that there are standard functions using like geogrid position and boundary discretized region for converting between georegions and regions that can be computed with. And the problem is that these funky objects right now can't be converted into regions. And so there are two solutions. I think over email, the idea was to maybe do both. One of them is to be able to, get the ability to run something like boundary discretized region on some weird filled curve like this. the other thing would be
Right, it's really I think it's really the geo group that's the problem, right? I don't think that filled curve should.
no, the filled curve is also a problem.
Huh,
Okay.
okay.
But the geo, both of them are problems. So that's one part. The other part, I mean, there's also the fact that you'd have to run GeoGrid position around this, and I don't think GeoGrid position is smart enough to burrow its way all the way into all those geo positions. But the other issue is just, and this is a more complicated issue. It would be great if something like this returned something nice and modern like a geopolygon. But then apparently the problem is that, right now there's no versioning. When you call, entity value, when the server responds, it has no idea what version of Mathematica you're using. And so if you're using a version older than the latest version.
Yeah, that's not true.
Not true?
That's not true.
Yes, I've also learned recently from Francisco that it can be done.
Yep.
It can be done.
So we could return GeoPolygon in more recent versions.
That I don't know, but
well, why not?
Because I don't know how you would form it, but it's not right. So long as the server can be taught how to return GeoPolygon, it can return GeoPolygon to people that can use it, and while returning the old thing to people who can't use it.
Oh, then it seems like there's no problem here.
Yeah, so I mean, the only issue is how it makes the GeoPolygon, even though it might not yet know about GeoPolygons on the server because it might be running an older version.
Exactly.
Okay, but I think it can. Yeah. Okay. All right, we should wrap up here. Good stuff. We have to come back to this topic about system exceptions next time.
Okay.
Okay. See you all soon.